Hi, ho, students. Mr. Kaczynski with you. We're on section 6.7, practice your skills. 6.7 is modeling real world exponential data. Some of this is kind of review that we did back in, even section 1. Let's get after it. Rewrite each value in the form of either 1 plus r or 1 minus r, then state the rate of increase or decrease. So this 1.15 is 1 plus the 0.15. So that would be, I'm going to type this, go better for me, a 15% increase, I guess, is the way we're going to state that from the original amount. All right. I guess I could do this all with typing, couldn't I? Excuse me. Let's call this 1 plus 0.08, which is a 8% increase. And then we get into these here. Let's put that up. Where this can be written as 1 minus something. 1 minus what? 0.24. 1 minus 0.24 is 0.76, and that's why it's a 24% decrease. All right, next up. Ooh, really tiny decrease here. 1 minus what? 0.002. So that is a 0.2% decrease, less than 1%. And lastly, when we write this as 1 plus something, it's 1 plus, 1.5, which is a 150% increase. All right, we've seen those before. Moving on. Does this equation right here model an increasing or a decreasing pattern? This is a decreasing pattern. Do I not know how to spell decreasing? I don't. Decreasing pattern. Because the base, which is what, 1 minus 0.12, is less than 1. What is the rate of increase or decrease? Well, that's a 12% decrease. You can see it right there. What's being subtracted from 1? The 12% decrease. What is the y value when x equals 13? So essentially, we're being asked to figure out y, which is 47 times 1 minus 0.12 to the power of x, and they're giving us that this is 13. Looks like calculator work to me, but hopefully you're showing how you obtained the answer by maybe writing an expression like I did. To the power of 13, what's that come out to? Oh, about 8.9. How about that we say that? About 8.9. That is not a pretty 9. I can do better. There we go. What happens to the y values as the x values get very large? Well, I'll tell you what happens. The y values will get very small, but never reach 0. Very small, but never reach 0. So if we graph it, maybe we should take the time to graph it. Go to y equals, we'll go 47 times 1 minus 0.12 to the power of x. Set our window. We'll start it at 0 for x max. I don't know, what's really big, 1,000? And we'll make our y minimum 0 and our y maximum, let's see, Initial amount 47, so we'll call it 50. Let's graph that. Oh boy. 1,000 was way too big. Doesn't very much get a good look at it. How about we go to 100? All right, there's our curve a little bit better. If we trace it, you know, we can start tracing this thing to the right, and you can see it right there kind of floating along the edge. You know what, maybe a better window. How about this? Let's go y minimum -10, so we can see it a little bit better. There we go. Trace it. And see here, as we get towards 100, you know, it's very, very tiny. And so tiny that it's now in scientific notation, 10 to the -4th. Okay, and we can keep going, and it'll never actually hit 0. It might actually. Your calculator might eventually read it at 0, but your calculator is just wrong. All right, write an equation to model the growth of an initial deposit of $250 in a savings account. An initial deposit of $250 in a savings account that pays an annual interest rate of 4.25%. All right, let B be the balance of the account. T represent the number of years. Got it. B is our balance for an initial amount of $250 times 1 plus 0.0425. There's our 4.25%. And really, I color coded this, but then I stopped color coding. How about 0.0425? There we go. To the power of t. Done. And then we're going to use our properties of exponents to simplify these expressions, something we can't lose practice of. For A, I'm going to simplify that right side a little bit. I'm going to do 3 to the 3rd power is 27. X to the 5th power cubed, I'm going to do 5 times 3 is 15. 4 times 27 is 108, and x times x to the 15th is x to the 16th, as in 1. Oh, wait, that's a 3. That changes things, doesn't it? If that's a 3, that makes this an 18. Got it. Next up, 60 divided by 15 is 4. X to the 8th divided by x cubed is x to the 5th. 8 minus 3 is 5. Y to the 4th divided by y is y to the 3rd, as in 4 minus 1 is 3. So 4x to the 5th, y to the 3rd. Ooh. Let's see. This times this times this times this. 3 times 5 is 15. But then if I do 2 to the x times 2 to the x, I'm going to keep that base, and I need to add the powers. X plus x is 2x. Well, that's a weird one, isn't it? So 3 times 5 is 15. 2x times 2x is 2 to the power of 2x. That one's up there. I like that one. What do you guys think? All right, what do we got here? I think I'll simplify the top and simplify the bottom and then simplify the whole fraction. 8 squared is 64. X cubed squared is x to the 6th. 3 times 2 is 6. 4 cubed, I think that's 64 as well, isn't it? I should know that, but I'm going to check. 4 cubed is 64. Yeah, that's good. That makes things easier. And x squared cubed is x to the 6th. I mean, we've got 64x to the 6th over 64x to the 6th. That's just 1. 64 divided by 64 is 1. X to the 6th divided by x to the 6th is x to the 0, which is 1. So 1 times 1 is 1. Simple fix here for E. Watched a lot of people struggling with this on the checkup. It's just y to the 4th over x to the 3rd, and we are done. Whereas this one is 1 over all of this stuff raised to the positive 3rd power, and then we can go ahead and simplify that. 2 to the 3rd is 8, x to the 3rd is x to the 3rd. Could I have raised both things to the negative 3rd power, then flipped them to the bottom? Sure. 2x raised to the third power. So when we're doing a power to another power, we're supposed to multiply those powers. So what's x times 3? It's just 3x. So 2 to the power of 3x is all we can do with that. These both have the same base, 2 and 2. So what are we going to do? We're going to add their exponents. So 3x plus 4 minus 3x. But that can be simplified because there's like terms. 3x minus 3x is 0, so it's just 2 to the 4th. And 2 to the 4th is 16. So that original ugly, ugly expression actually just equals 16. That's all I got for you. I really hope that was helpful. If it wasn't,